infrared SBIRS, one of the nation's highest priority space programs, is designed to provide global, persistent, and taskable infrared surveillance capabilities to meet 21st century demands in missile warning and defense, technical intelligence, and battle space awareness. The system architecture consists of legacy Defense Support Program satellites, hosted SBIRS sensor payloads in highly elliptical orbit, and dedicated SBIRS geosynchronous Earth orbiting satellites. The satellite constellation is supported by ground infrastructure which receives, processes, and delivers the infrared information to key decision makers. Lockheed Martin is the prime contractor for the program, with Northrop Grumman serving as the payload integrator. The SBIRS team is led by the Infrared Space Systems Directorate at the U.S. Air Force Space and Missile Systems Center and operated by Air Force Space Command. Recently, the launch team received a final weather briefing and was told the weather is within the launch commit criteria for this afternoon's launch. The weather briefing provided the following information. The probability of violating launch constraints is at 30%. The ground winds are 15 knots out of the east-southeast. The upper level winds are favorable, and the temperature is 75 degrees Fahrenheit. So we are proceeding towards liftoff with a planned T0 of 5:21 p.m. Eastern Daylight Time. ULA is using the Atlas V 401 configuration to launch the SBIRS GEO-2 mission. This is the 37th Atlas V Evolved Expendable Launch Vehicle flight since the inaugural launch in August 2002, and the 619th Atlas program launch overall. The Atlas V is produced in Decatur, Alabama and Harlingen, Texas. It is comprised of a Common Core booster powered by the NPO Energomash RD-180 main engine and a Centaur upper stage powered by the Pratt & Whitney Rocketdyne RL-10A engine. The SBIRS satellite is encapsulated within a 4-meter diameter payload fairing that will protect it during ascent. On March 4th, the SBIRS GEO-2 satellite was encapsulated in the 4-meter diameter payload fairing. The encapsulated payload fairing was mated to the Atlas V rocket on March 7th. The Atlas V is prepared for launch at the Vertical Integration Facility, or VIF. The VIF is located approximately 1/3 of a mile south of the launch pad. The fully integrated Atlas V was rolled to the pad at Space Launch Complex 41 yesterday at approximately 10 a.m. Eastern Time. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a trip that takes approximately 30 minutes to complete. The Atlas V rocket stands 188 feet tall, or about 19 stories, and weighs more than 700,000 pounds fully fueled. At liftoff, the RD-180 engine produces more than 860,000 pounds of thrust to begin the vehicle on its journey. For those watching the broadcast, you're looking at video taken yesterday at Space Launch Complex 41. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses a flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes launch final preparations, let's take a closer look at today's flight.
The following profile details the important events of this mission using approximate times. The Atlas V rocket will launch the space-based infrared systems satellite for the United States Air Force.
This is Atlas Mission Control at T-minus 5, 4, 3, 2, 1. And the RD-180 engine roars to life and liftoff.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 81 seconds. At 91 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour, and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Cutoff of the Centaur main engine follows an 11-minute burn. The mission now enters a nearly 9-minute coast phase. At just over 24 minutes into the flight, the Centaur main engine is started for a second and final burn. This burn will last nearly 4 minutes. Following the second Centaur main engine cutoff, the mission enters a final coast phase. This coast phase will last nearly 15 minutes. At 43 minutes 19 seconds, Centaur releases SBIRS for the United States Air Force.
F-1750, launch on time verified.
Roger. Switch to ready position.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in the planned 25-minute hold as preparations for the launch continue. Launch conductor Scott Barney will poll the launch team in a few moments for the final go to resume the launch countdown. 27 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2. Go. LH2.
Go.
Hazgas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Range, weather, and clear to proceed.
Go.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. T0 is planned for 2121 Zulu. Set count to start at 2117 Zulu.
Roger. T0 is set for 2121 Zulu. Count will start at 2117 Zulu.
The polling is complete and the launch team has given the go for launch. The countdown will resume at T-minus 4 minutes, approximately 2 minutes from now. From T-minus 4 minutes until launch, you will be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. At T-minus 3 minutes, the team will secure Atlas LO2 topping. At T-minus 2 minutes, the team will transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch, enable, and arm the flight termination system. At T-minus 40 seconds, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures at T-minus 30 seconds. A final status check of Atlas, Centaur, and SBIRS readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. This is Atlas Mission Control at T-minus 3 minutes, 50 seconds and counting. The countdown clock has resumed, and we are go for launch at 5:21 p.m. Eastern Daylight Time.